Welcome back to another Explainer. Today we're looking at a pretty massive shift in how we tackle one of the toughest challenges in all of medical science. For decades, right, the medical community has been hunting for less invasive, more comprehensive ways to screen for disease. And honestly, rather than some crazy sci-fi leap forward, what we're actually seeing is a fascinating evolution in how we apply data analysis directly to human biology. We're talking about the exact point where oncology meets machine learning and how that convergence is opening up entirely new frontiers in early cancer detection. It's moving us from just localized physical screening to a totally systemic, data-driven approach. Okay, let's dive into this.
What if one simple blood test could help detect dozens of different cancers? I really want to pause for a second just to let the sheer mechanics of that question sink in. Because, we aren't talking about stepping into some neon-lit futuristic lab with robotic arms everywhere. No, we're talking about the exact same standard clinic you already visit for a routine physical. You give an ordinary blood sample, literally the exact same kind they use to check your cholesterol or your vitamin D levels. But here's the kicker. Instead of just running standard metabolic panels, that single, quick draw could be used to screen your entire body for a whole bunch of different cancers, all at the exact same time, through a process called a liquid biopsy. So for you, the patient, the physical experience is totally normal and familiar. But the immense analytical power happening behind the scenes on that sample, that represents a completely unprecedented approach to diagnostics.
And that brings us to the core scientific breakthrough happening right now. Scientists are developing AI-powered blood tests that are designed to spot the absolute earliest, most subtle biological markers of multiple cancers. Think about it. For a long time, so much of oncology has basically been reactive medicine. We wait for a patient to actually show physical symptoms, or we rely on localized screening, like mammograms, colonoscopies, or CT scans, just hoping to catch a tumor once it's already big enough to physically see. But what we're looking at here is a complete paradigm shift toward proactive, data-driven screening. By training artificial intelligence on massive data sets of blood samples, literally comparing the molecular profiles of healthy people against thousands of known cancer patients, researchers are leveraging advanced pattern recognition. They are identifying physiological warning signs way before a tumor would ever show up on a traditional scan.
Now, what's really interesting about this slide is how elegantly this breaks down into a simple three-step clinical process. First up, collect the blood sample, standard procedure. Second, the AI takes over the analysis. So rather than just checking for general inflammation or your basic white blood cell count, the machine learning model maps millions of individual molecular data points within your blood plasma. Millions. And finally, step 3, the AI searches for and finds these microscopic cancer-related signals. Specifically, it's hunting for anomalous protein structures or tiny fragments of tumor DNA, often called circulating tumor DNA. See, as cancer cells grow and die, they actually shed bits of their mutated genetic material right into the bloodstream. So the algorithm is basically sifting through a giant haystack of normal cellular debris to find the specific mutations that serve as the absolute faintest digital footprints of a developing disease. These are footprints that a human technician using traditional testing would completely miss, simply because we don't have the capacity to process that sheer volume of microscopic data.
So the crucial point is understanding exactly where the algorithm stops and where human expertise actually begins. The AI's role? It's strictly analytical. It processes all that complex molecular data from the blood and flags those tiny anomalous signals. It's essentially acting like this highly advanced ultra-sensitive radar system scanning the body for potential threats. But the physician is still the navigator. Human doctors review the AI's output, they contextualize it with your personal medical history, and then they determine the necessary follow-up tests, like targeted imaging or a traditional tissue biopsy, to actually make the diagnosis. And this dynamic is absolutely critical, right? Because highly sensitive tests can sometimes pick up on totally benign anomalies. The doctor's expertise is required to filter out the noise and figure out what's clinically relevant. So while these AI tests, which are in active clinical study right now, are incredibly sophisticated early warning instruments, they are absolutely not a replacement for a trained oncologist's judgment.
But even as a diagnostic aid, rather than a standalone replacement for your doctor, the promise here is just highly impactful and grounded in really solid data. As our source notes, while they don't replace doctors, they could transform early cancer detection. We all know that cancer is an adversary that fundamentally relies on the element of surprise. Survival rates plummet the second a disease metastasizes and spreads beyond where it started. By arming doctors with this level of microdata, we're basically giving them a massive head start. Catching that circulating tumor DNA months, or maybe even years, before a localized mass ever causes symptoms, that could dramatically shift how we do early intervention. It means moving away from aggressive, late-stage salvage operations and moving toward highly targeted, localized, and statistically way more successful early treatments.
Which brings us to a really fascinating and honestly very personal question for you to consider. Would you take an AI-powered blood test? Knowing that it acts as this highly sensitive radar for your doctor to investigate further, is this the kind of proactive medical technology you'd want in your routine annual checkup? It's kind of an interesting psychological proposition. I mean, some folks might feel pretty anxious knowing their blood is constantly being scoured for any potential anomaly, maybe stressing over a false positive. But others? They might find immense peace of mind having that early warning system flipped on, knowing they are doing literally everything possible to catch an illness at its most treatable stage. Because as this tech transitions from clinical trials into our local clinics and routine healthcare in the coming years, well, this is a reality we're all going to have to navigate.
If you enjoyed this explainer and you want to stay on the absolute cutting edge of developments like this, make sure to follow Future Tech Insider. Hit that like button and subscribe for more amazing medical tech stories. Thank you so much for learning with me today. But as we wrap up, I want to leave you with one final thought to chew on. As our machines get exponentially better at reading the deepest, most microscopic levels of our biology, how will that ultimately change what it means to go to the doctor? Are we just going to become mere data points for an algorithm, or will this empower us to take completely unprecedented control over our own health? Think about that, and we'll see you in the next explainer.